In this video, what we're going to look at is a cubic, finding a cubic function. Now, cubic is y equals ax cubed plus bx squared plus cx plus d. Now, we follow the same principles as we do with quadratics, okay? We need to understand vertex, we need to understand roots, we need to understand all those things to help us. We need to understand if it's an imaginary root, if it's real, if it's touching at if it's touching the x-axis, or if it's cutting the x-axis. Because in this case, this cubic touches at 1, 3, and -4. So that means that's our x-intercept. We've got -4, we've got 1, and we've got 3. It's going to look something like this. That's our cubic. It cuts. We don't know if it's positive or negative. I'm just guessing by that drawing. So I know it cuts. So they're our roots. So that means our equation is going to be a x take 1, x take 3, x plus 4, and a cannot equal 0 because it's cutting. It's nothing else, it's cutting. So they're our roots. So that means when x equals 1, x equals 3, and x equals -4, y equals 0. So that's our roots. But we know when x equals 2 and y equals when x equals 2, y equals -12. So when we want to find a, to find out exactly what this is, we use that information. So that becomes -12 equals a, which is 2. A is a. X is 2. 2 take 1 times 2 take 3 times 2 plus 4. Well, a doesn't equal 0, obviously. And we go through. So -12 equals a times 1 times -1 times 6. So -12 equals -6a. A equals 2. So therefore, our cubic, in this case it's a cubic, remember that, is y equals 2, x minus 1, x minus 3, x plus 4. And that is our cubic. Okay? And that's how it's very similar to what with quadratics, but with cubics we have 3 roots, not 2. Right? Hence the x cubed. Alright, what I'll do is I'll do another one underneath here. I'll just move this up. I'll do another one. So if we have a look now, if it touches, so we'll say it touches at -2, and it cuts when the x-axis at 1, and it goes through the point 3, -100. All right, what you'll notice first thing, we don't have 3 roots. It's you're going to be thinking, wait a minute, it touches, but it cuts at 1. The language is what gives it away here. It's the same as quadratics. When it touches, well, then we have a root that's repeated. So that becomes x. Oh, what happened there? We have a root that's repeated. So that becomes x plus 2 squared. All right. X take 1. And a cannot equal 0. So when it touches, we're squaring that root. When it cuts, we're minusing it or adding it depending on what the sign is, because it intersects. So, but we know, we need to find a now. We know that when x equals 3, y equals -100. So, -100 equals a. x3 plus 2 squared, 3 take 1. It's -100 equals A. 5 squared. So we take 1 is 2. Well, minus 100 equals A. 25 squared is 25. That's 50. A equals -2. So, therefore, our cubic is -2 x plus 2 squared x minus 1. Which means, if we were looking at this graph, if we would say that was -2 and that was 1, the graph would probably look something like that. Obviously, 3 -100 might look something like that, okay? Being a negative square root. But yeah, makes sense because 3 would be over here somewhere and 100 would be all the way down south, down there. Okay, so that's a rough idea of what it might look like. If you've got a graphics calculator or graphing package, check your answer.